Hi, my name is Nicholas Espinal. This is my 8th question for my Chapter 26 quiz, and this is what it asks. A resistor is made out of a long wire having a length L. Each end of the wire is attached to a terminal of a battery providing a constant voltage V0. A current I flows through the wire. If the wire were cut in half, making two wires of length L/2, and both wires were attached to the battery, the end of both wires attached to one terminal and the other ends attached to the other terminal, what would be the total current flowing through the two wires? So first we have to ask yourself, how are length and current related? Well, from Ohm's law, we know that voltage is equal to current times the resistance. And we also know that resistance has the formula rho times L over A, where rho is the resistivity, L is the length of the resistor, which is in this case the wire, which has its own resistance and acts as a resistor. And A is the area of the resistor's cross-section, where the resistor is again the wire. So it's the cross-section of the area of the wire. So we can rewrite Ohm's law as voltage is equal to I times rho times L over A. So with this, we are given that the initial voltage, the constant voltage, is V0, and it's still equal to this equation. Now, if we cut the length of the wire in half, we're going to cut L in half. We're going to replace it with L/2. So we're going to get a new equation where we divide L by 2, and you're going to get the voltage is equal to the current times rho times L all over A times 2, where we just divided L by 2. So we have this new equation, and since the voltage, the cross-sectional area, and the resistivity remain constant, the only thing that can change would be the current, I. So in order to keep the voltage constant, which is supposed to remain constant, we're going to need to multiply the current by 2. So we're going to get this equation again where we multiply the current by 2, we're going to get our initial resistance, our initial voltage again. So the new current on each wire when we cut the wires in half is going to be 2 times the initial current on each single wire. But we cannot forget these wires are in parallel now. So using Kirchhoff's rule, we know that the current in is going to be equal to the current out, where the current in is the total current and the current out is going to be the current on each wire. And we know that each wire has a value of 2 times the initial current. So if we're going to add these two, 2 times the initial current plus 2 times the initial current, it's just going to be 4 times the initial current. So the total current going through the wire is going to be 4 times the initial current. So when we look at our answers here, we're going to see that answer choice C, total current equal to 4I, is the answer.